Yeah.
So I think we can start.
Okay.
So guys, welcome to our first lab tour for this semester. And let's welcome our professor. So you can introduce yourself.
Sure. Thank you very much. Thank you, Alima, for this time and inviting us to this program. My name is Peyman Pourafshary. I am Associate Professor in Petroleum Engineering Department in the School of Mining and Geoscience. Well, today I'm happy that one of our best PhD students, actually two of them, are here with us. So would you please introduce yourself so we can continue?
Hello, everyone. Good afternoon. This is Rizwan Muneer, third year PhD Petroleum Engineering student. I joined Undergraduate University in 2019. So currently I'm in third year and I'm working on my research activities.
Good afternoon, everyone. I am Mariam Shakeel. I am first year PhD student at School of Mining and Geosciences. And I did my master's from Undergraduate University this year. So I was involved in lab experiments and all the lab activities. We performed different experiments for oil recovery in this lab. So today we will give you a brief tour of the lab and the operators that we use for oil recovery experiments.
Okay, thank you. Thank you very much, Rizwan. Thank you, Mariam. So today our target is to introduce what we do in all labs in petroleum engineering. And well, we assume that our audience, they are not in this field. So we try to show you something interesting about how we somehow improve the oil recovery. So what we do generally to design this stuff. So this is something that I think it's interesting for people that who are not very familiar with oil industry and petroleum engineering. Well, the lab that we are now, actually our PhD students are there. This lab is for oil recovery lab, or something that is called enhanced oil recovery lab, that we measure rock properties, fluid properties, and different mechanisms that we can use for the production of oil. Now, first question, I think that it would be interesting for you. So where is the oil? So when we talk about petroleum, when we talk about oil, what do you think? I mean, if we drill a well, is it something like a huge reservoir beneath the earth, inside the earth, or no, or oil is somewhere else? So maybe Rizwan, you can show us where is the oil.
So here we have basically the subsurface rock sample. So here we have it basically in cylindrical form, basically. So we use for flooding system, and we also have the crude oil sample from the actual field. What we do basically, so actually, if you consider the rock sample subsurface, and this rock sample is basically saturated, or you can simple word you can say full of this crude oil. And I can show you another rock sample what we saturated.
Okay, so you see that, guys, this is oil is like this. You see, it's not like a big pool in the earth. The oil is in the pores of rocks. So when we take a piece of rock from the earth, you will see something like this, black, and this, I mean, the dark color that you can see here is the oil. That is it in the pores between the grains of the rock. So, and you know that, Rizwan, would you please show both of them? Both, of course, please. Yes. Okay. You see that this is the difference. The one that is white is without oil. The other one is with the oil. So it means our main job is somehow to produce oil from the rock and make it clean and extract the oil. So this will be something that you can see that comes out of the wells, and we consider it as a source of energy. Now, this is the question, how can we produce this oil? This is the main question. So when we drill a well, some of the oil comes out of these pores, but you know that you are talking about oils compressed between pores of rocks. So normally they don't want to move, so they want to stay there. So one of the jobs that petroleum engineers do, they want to design different ways to extract the oil from these rocks. So, and in this lab, one of our main targets is to work on these methods, to find out which method is the best one. For example, for a field in any country, in Kazakhstan, in other countries. So when we want to work on that, okay, what method you want to use to recover oil? For example, one very simple way, consider that if we inject water to this rock that Rizwan showed you, so water will move, push the oil out. Okay, this can be one way. We call it water flooding. Other way, considering, for example, injection of some kind of chemical, like when we wash our hands, you see, this is something that we have, or if your hand is dirty with oil, how you clean it? You wash it with some kind of chemical, with soap, okay? So we can do something similar. We inject something like a soap, and by that we can produce oil. You know, these are, all of them are theoretical, ideas. So how we can prove it in the lab? Today, I want to ask our PhD student, Rizwan and Mariam, to show you one of these kind of tests. Actually, not the test, because it takes time, so you don't have time to show it to you here. At least the basics, that how we can work and, analyze and design one of these methods. So Rizwan, what method do you want to show for us?
Yes. Okay, so I can start from the start, initial basics. What we do basically, we have long core samples. So initially we cut small pieces, like in the form of pellets. So why do we do this basically? So we want to check the interaction of rock and, as I have shown you. So we want to check the interaction, like whether this rock is oil wet or water wet. And, we do different tests. For example, and show you maybe if it is clear to you. So what we do, so we put these pellets into the crude oil for a specific period of time, just to check the wettability, like whether the oil is coating the rock surface, and then we check the wettability, the contact angle, and all these things. These are basically the technical terms, but I can just show you. So what we are doing, we are just mimicking the actual reservoir condition. So in the actual reservoir, so our condition is like similar to this one, like the rock sample is full of like oil and water as well.
Yeah. Then, so but to complete this, you see, when Rizwan talked about interaction, it means that, for example, we have a rock and oil is on that, similar to this one. You see there, this rock is in this bottle with oil. Now, if we have this piece of rock, how we can extract and remove oil from it? So different methods. So from the interaction, it means that what kind of chemical, what kind of water, what kind of, I don't know, thermal method is good to remove the oil, to separate the oil from the rock. So we are looking for these interactions. And now Rizwan is showing you one of these cases on a piece of rock.
Yes. And after this step, what we do basically, depending on the different scenarios. For example, so here I have the example of engineered water. So that is basically the water made up of different sorts present in there. So I can show you what we have in our lab. We have a number of with us, and types of water based on, and this our design. So different groups basically, so they are working on different parts. So for example, one group is working on engineered water. So that is basically made up of a specific combination of different salts. What we do, so we take the pellet from the crude oil, as I have shown you previously. So what we do, so we immerse that pellet into that.
Well, Rizwan, I think your voice is not clear, so maybe I can explain. So I think you just be in front. Okay, so you see that, for example, here in this test, we want to design one type of water. So what does it mean? It means that we adjust ions in a water. You know that when we talk about water from seawater or some water that we get from the environment, lots of salt and ions are in it. So by adjusting them, we can make it somehow useful to extract the oil. And here, this test is something that Rizwan is showing you, that how we can check different types of waters to extract this oil from the system. Okay, continue, please. I don't know. Alima, can you hear, or we have the problem in the voice?
Sorry, Mr. Rizwan. I think some problems, yeah.
Yeah, I think there's a problem with your voice.
Microphone, maybe.
Yeah, maybe microphone. Can you check?
Okay, okay, I will.
Yeah, it's good.
Now it's clear.
It's clear now.
Maybe the internet issue in the lab.
No, it's fine. No, it's fine. Continue.
Okay, okay. So after that, so what we do, so we immerse those pellets from the crude oil sample into our design water for a specific period of time. After that, what we do is we check the wettability. If the wettability shift is there from like oil wet to water wet, initially the oil was coating the rock surface, so now it should be water coating the surface. So in that case, we may have the accident recovery in the next step. So what I will show you in the core flooding test.
Yes. So as I hope that you understood up to now, we do several tests in this lab to study the interactions between the rock, the oil, and the chemical and type of water that we use. And again, the main idea is that we want to produce oil as much as possible. Now, but in reality, something that we do is that we inject something to the reservoir, to the rock. So we inject something and the oil is produced. And this is the main target that in this lab, our students and our researcher, they are working on that. So I think, Rizwan, you can show us how you work with core flooding system. Yes. I mean, when Rizwan is preparing, I'm explaining to you that the idea here, we want to mimic exactly what is happening in reality in the field. For example, if we want to inject water, so what was happening? Oil is inside the earth, underground, so we inject water to push the oil to producer and produce it. Same thing for chemical, same thing for thermal method. And this is exactly one idea that we do it here. So I want Rizwan to show you that how they do something that is called core flooding. It means flooding to a piece of rock. Okay, this whole system is the core flooding system. So in this whole system is designed for this idea that we can exactly try to mimic what is happening in the field. So as you can see, there are some cells here. These cells will be full of oil, water, gas, whatever that we want to use. So we keep this cell at high pressure, high temperature, because this is something that in reality happens. We are talking about hundreds of meters underground. So at that place, pressure is high, temperature is high. So we need to have something in that condition. And then we start to inject. So Rizwan, if you are ready, we will listen to your explanation. I don't know if you are talking or not, but we cannot hear you. Okay, now it's good. Now. We don't have the voice, Rizwan. Yeah, now we have it, but you need to be close to the microphone. No. No voice. Do you have? It's better. Yes, yes.
So now can you hear?
Yes, now it's better. Yeah.
Okay.
Yeah, maybe if if possible, please turn off the other camera on your computer.
Okay.
Okay, now it's good. Yes.
Okay. Okay, sir. So now I can explain. So
Yes,
as I
please.
have shown you, the rock sample, which is like saturated with the crude oil, as I have shown previously, this one. So the initial step, so what we have to do, so we have to we have to install this core sample into core holder. So this is our core holder. So the procedure is very simple. So I can show you. So here we have a sleeve, whitened sleeve. So what we do basically, so we install the core into this sleeve just to isolate it properly, and because we have to apply confining pressure over this sleeve. So that's why. So what we want basically, so one side basically our injection side, for example, if just assume, so this is the injection side and this is the production side. So what we want basically, so we should inject on this side and we should produce on this side. So that's why we have to isolate, we have to confine the core sample along its length basically.
Okay, so sorry, Rizwan, I interrupt you because I want to explain something. You see, I told you we need to apply pressure because in reality we have pressure. So we put it in this kind of a sleeve under the pressure, so it will be very similar to the rock underground. So it will be exactly similar to that. So when we inject water, it will be very similar that later what we want to do later in real fields. In reality, what industry wants to do.
Okay, so in the next step, so what we do basically, so we install this sleeve into the core holder like this. So I'm just showing you in a simple way. And next, what we have to do, so we have to make this end fix. Okay. So these are basically the connection. So we have to make in the next step. So here, like we make connections, and these connections, so these lines, so they are coming from these two accumulators. As Dr. Peyman explained, so in these accumulators, so we may have different fluids. So let's suppose I'm using the same engineered water in one of the accumulator, let's suppose. So what we do, so we have to have this assembly installation. So this is the inlet side, and what we do, so here we have the outlet. So we have to connect it here properly. And here we have a back pressure system as well, just to have like smooth outflow. And in the next step, so what we do basically, so here we have a pumping system. And this pump is basically like connects both of the accumulators. And these accumulators, so they have pistons inside them. So, and what happens basically when we start injecting, so this system, this pump takes water from this reservoir and it injects here, or let's suppose if I'm using this one, it is connected right now. It injects water at a specific flow rate, and what happens? Piston moves to the forward, and here we have our designed water, or maybe we have polymer, maybe we have nanofluid. So what happens? So that nanofluid is pressurized, or that engineered water is pressurized, and it is injected through these lines into the core sample. And then we have a recovery at the outlet using this configuration. If I can show you on this side. And what we have what we have after the completion or during the completion of experiments. So here I can show you some of the results. So we performed a latest experiment last week. So in the first tube, so what we got maximum oil or 100% oil. So that oil is basically from the rock sample I have shown you. But now it is collected in a specific manner, in a pressurized manner, basically. And in the next tube, so what you see basically, so maximum oil, maximum water, and less oil, because now the maximum oil in this section is already being produced, and now the water is also being produced. And now you see the oil volume is decreasing and the water volume is increasing. So that's something related to oil recovery from a specific core sample.
Very good. So now consider if we have this production, what we can get. Okay, so for example, I'm just showing you one result that I just received. This is the work done by Mariam as we met her at the beginning. Look at here. This is one of the results by this device. In this case, for example, we want to study the effect of one kind of chemical and gas injection. So by these samples that Rizwan showed you, at each time of injection, we can measure how much gas, how much oil we produce, and what is the pressure. So we can have something like this, some curves like this that show us that what is this recovery factor. Okay, so for example, 80%, 90%. So it means that now we can produce 80% of the oil by this method. Now consider we are working in a company. So what will happen? We are working on a field. We have several options. So by this kind of device, we can compare these methods to each other and find out which one works better. Okay, so we can just, for example, this can be a very good tool to explain to us that which method works better for this system, for this oil, for this reservoir, and technically, and later, I mean, about the cost, everything, so we can decide how we can produce more oil in a cheaper way. So, I mean, I just want you to think about this issue, that everything that we do in this lab is in a close relation with what is happening in reality in industry. Now, well, I want to ask Rizwan and Mariam to explain to you, for example, what kind of test we can do by this device. I mean, what kind of material we can use generally. Can you just give us some example of what type of material we can use for oil recovery? I mean, what are
yes,
the new methods, something like this?
Yes, sir. So initially we performed some experiments like simple one. We used water flooding, and after that we also used surfactant flooding. So we can use this device to test the potential of surfactant flooding. Then we can also inject polymer using this device. Polymer is basically a material that is used to increase the viscosity of the water. So if the viscosity of the brine is increased, so it will have more viscous forces to produce the oil or to push the oil, and we can get more recovery. We also tested different polymers in this device, and we selected the best combinations of surfactant and polymer in our previous experiments. Then recently, we tried to use this device for gas flooding as well. So what we did, we connected, I can show. So this is a gas cylinder, a nitrogen gas cylinder, and the pressure of the cylinder is around 2000 psi. So we connected this cylinder through this line, and here this line, it is basically coming from the gas cylinder, and this is a valve to control the flow of the gas. And this line, then we connected it to the one of the accumulator here. So now we have a gas source. So we filled this accumulator with gas, and then we injected this gas into the core sample to see the recovery by gas. Because normally in oil reservoirs, the recovery by gas injection is very low because of very low viscosity of the gas. So we wanted to study how can we improve the recovery by gas flooding. So we first injected gas, then we designed a nanoparticles and surfactant mixture solution. because nanoparticles and surfactants, they are good stabilizing agents for foams, and they can create foams when they combine with gas. So we filled this another accumulator with our design solution, and in our core sample there was some already gas inside the core sample. Like this sample, it was there was some gas already because we flooded it with gas, and there was also some oil which could not be produced by gas. So when we injected the nanosurfactant solution in this core sample, the gas mixed with this nano and surfactant solution, and a foam was generated, which we recovered from the outlet. And along with this foam, we also produced additional oil, like this oil volume. It was basically produced during foam flooding. So this was a new technique that we tested on in this device. So I think we can do a lot more other techniques as well using this device, and we can.
Thank you very much. Yes, exactly. So you know, there are different new technologies. So and we can check these technologies, for example, application of nanotechnology, different chemicals. I mean, something like, for example, foams. So there are different methods that we can apply here to find at what case we have better oil recovery. So I hope that now you get a a big picture or idea of what is happening in this lab. Now, in this lab, also we measure other properties of the rock. Okay, so for example, any piece of this rock that Rizwan and Mariam showed you, sometimes we need to know properties of this rock. For example, we need to know how much pores are there. So I mean, are there something porous or something tight? Or maybe we want to know that how fluid can flow from this rock, something that in petroleum engineering we call it permeability. So I mean, all of them together is something that we call it rock properties. And very good that when I'm talking, Mariam is showing you the devices that we can use them to measure porosity, measure permeability, measure other parameters. So I mean, when we have a rock, we try to first calculate, measure, and observe these properties to know that what type of rock we have. For example, do we have something very tight that oil production from is difficult, or we have something with higher porosity, higher permeability? So I mean, the idea that here in this lab we are looking for is somehow to understand properties of the rock and the interaction between rock and different fluids. So is it possible, Rizwan, Mariam, to quickly show our students other devices in this lab? I mean, for porosity, I don't want just show them the device and what they do, so they understand what is the main purpose here.
Yes, sir. So here, sir, we have core saturator. So basically what we have to do, we have basically the dry cores. So we have to saturate initially with the designed water just to have the subsurface reservoir conditions. And normally we saturate the core sample at around 1100 to 1200 PSI for almost 1 day, just to have the maximum saturation.
Yes, very good.
And here it is already explained by you. So we have a Helium Procemeter. So this device basically is used to measure the porosity, the void, the spaces, the interconnected spaces into the core sample. So basically we need that value just to find out the pore volume, how much the pore space we have. So we use this device.
For audience that do not have the background in petroleum, it means that we want to see that how much voidage is in this rock. So how much oil can be stored in this rock. Okay, for example, you see that here we are talking about a piece of rock. So there are porous space in there. Maybe, I don't know, 5-6 cc of oil can be stored in this rock. So this is the important parameter, and we call it porosity. So by this device, we can measure it.
And the next I can show you, so this apparatus, so we have basically, it is a multi-purpose apparatus. So we can measure the porosity as the helium procemeter, and also we can measure the permeability. So permeability basically is the ability of
Rizwan, your camera, I think it stops. So just now it's better. Yeah.
okay. So this device basically is so it is able to measure the porosity and permeability as well. So permeability basically is the ability of the fluid. So like how easy a fluid can move from a specific rock. So that property, so we can measure with the help of this device.
Yes, very
and
good.
we have some apparatuses in this lab as well. So this one basically small apparatus. So it is used to measure the electric properties of the rock sample. So basically, electric properties are basically due to the presence of saline water in the rock surface. So based on these electrical properties, so we can also find how much pore space is there in the rock surface. Another apparatus we have here, so that is basically used for the capillary pressure measurement.
As I hope that understood that the idea in this lab is to find properties of the rock that we drill from the reservoir, from the well, and bring it to this lab. I don't know, Alima, how long do we have time? So is it possible? I think if anybody have question, we can answer now.
Yes, I think we can start our Q&A session.
Yes, so yes, we are ready if there is any question.
So actually, you said that this lab can be transferred to the industrial like processes. Yeah.
Yes.
So
well, yes, please go ahead.
And like, is it calculated all the drawbacks, all the errors in the research, or it is like it is practically calculated?
Well, actually, the way that we do it is that we experimentally measure all of these parameters, okay? But for sure, there will be error in our calculation because we are talking about a rock. You know, the main assumption here is that this rock that we have is similar to what is happening in reality in underground in a big field. So you know that it is not a very good assumption because in different sections of the earth, the type of the rock may be different. But this is the best that we can do. And for the industry, it is a very good start point to find that which method works better for them. And then later by combining these methods by something like simulations, modeling, they will get better answer. But in this lab, the main idea is to experimentally, to measure experimentally, yes.
Okay, thank you. Any other questions, guys? So I also have a question, like you talk about that like PhD questions like Rizwan and Mariam works in your lab. What about undergraduate students?
Yes, actually they are working there. Undergraduate student, master's student are working. And the reason I asked Mariam and Rizwan because they are more experts, and I asked them to be in this event today. But yes, many master's students, undergraduate students are working on projects or even for small projects during their courses. They use this lab, and yeah, if any student is interested in this kind of activities, we will be happy to start working.
Okay, guys, I'm not sure that you can speak. I'm not the host. If you have questions, you can just write to chat.
Yeah, actually, I don't know how it works, but I think if anybody raise hand or write something, I can see it here. Yeah.
So can you tell me about doing research in general? What is your experience?
Yes. Well, if I want to tell something related to this lab that we are working, uh, here we work on different materials for companies. For example, right now we just started a project for a company in Kazakhstan. They want to study injection of polymer, okay, to one reservoir in Kazakhstan, and to see that is it possible to recover more oil by injection of polymer. So you see that this is the question here that they have. They have different samples of polymer. They want to know which one works better. This is a very big question for this company. You know, they want to go and buy this polymer. They want to order it. Okay, which one from which company they can get it, and is it economical to use this method or not? The way that we can answer it is by our students, by our research team in this lab. So I mean, the research that we are doing here, both it is scientific and at the same time it is industrial. So the result, the answer will help the company to decide and I mean to reach to a conclusion. So I mean, this is something that I can give an example, or other methods that most of them are still in the research scale, for example, like application of nanotechnology, designing of water, so all of them. Okay, I can see some questions here. Okay, very good, Rizwan, you are answering. So yes, well, actually the last 2 years, because of this, I mean, the pandemic, we have much limitation in accessing the lab. But normally, the students can access the lab for their research in the 3rd year, 4th year. I'm talking about undergraduate students. But I mean, I told you in the last 2 years, we have many problems for the accessing the lab. So because of that, a few students just was allowed to work. Okay, Talga, thank you very much for your nice word. And yes, I don't know if there is any more question.
I also have a question for Rizwan. So, Mr. Rizwan, how you started your research? How long when did you start your research? Yeah.
I joined Nazarbayev University in 2019 August, and this lab I think in October, just after 1.5 months. So once my research idea is developed and I cleared my research idea, so on this topic I want to work. So I joined this lab, and since then, so I'm working in this lab. So this is basically, as I have shown you, so this is mainly related to core flood. And we have another lab, basically 2 other labs. So in that, basically, so we prepare some solution. So basically, I'm working on nanoparticles to control very fine particle in the rock surface, as I've shown you, this one. So in this rock surface, so we have fine particles, so very small, ultra fine particles. So sometime under different conditions, so they move along the flow. For example, if I'm injecting a specific fluid through this phase, and I'm producing that fluid through this phase, so what happens? So those fine particles, so they move under specific conditions. And whenever they move, they can plug some of the open space, as it is called porosity or permeability. So what I'm doing related to my research, so I'm using nanofluid, silica nanofluid. So those nanofluids, basically I'm preparing other lab, and then I inject those nanofluids in using this apparatus. So since 2019 October, so I'm working in these labs.
Well, I received another question. It's about the research opportunity. I think 1st and 2nd year students, I don't know, I assume that you are talking about undergraduate students. Well, I think 1st or 2nd year is a bit soon. If you want to join a lab, it's better to start a bit later because you need to have some background. For example, if you are in petroleum, at least up to year 3, maybe you need the background. If you are from other disciplines, I don't know which discipline, but engineering, it's good that you know something about thermodynamic, fluid mechanics, and then join the lab. And the best way is to contact, professors in School of Mining and Geosciences. So they will tell you if they have any active project, any opportunity. But as I mentioned, I think it's better to wait until at least the 3rd year of your study. Okay, I'm just trying to see that. Is there any other question? Yeah. Yeah, I think Alima, I answered all of them. So if you have any other points.
Okay, so I think that's all. I'm gonna thank you, our professors, Mr. Peyman and Mr. Rizwan, and also Mrs. Mariam, for this great presentation. We really appreciate this information, your time. So thank you for this event. It
Yeah,
was
thank
a
you
great
very much.
experience to cooperate.
Thank you, Alma. Thank you for the time. I know it's not a very good way to do it by Zoom or something like this, but I hope that you enjoyed it. Thank you very much. Thank you. Goodbye.
Thank you, all of you.
Yeah, goodbye. So
Goodbye.
one reminder, I will upload this video to our YouTube channel, so everyone can watch this video and like after this session.
Yes, thank you very much. Goodbye.